So this is a question from a student on the mathematical modeling problem. This is it's one, there's not a lot on this, so I thought I'd make a quick video and make it with my reply. And this is just a really good question. I like that the student here said, hey, I got the right answer, but I don't know how I got there. And that's exactly what I want you to do. When you're not sure, ask. And even if you've got the right answer, if you don't know, then you need to ask. And so this is a nice problem. And so I'll kind of work through this example and see if we can help clarify this for anybody that has any questions. So this is a working together problem. You have two people, Tommy and Huck, both are painting the fence. Tommy can paint the fence by himself in 12 hours. Together they can paint it in 1 hour. And what we're after is how fast could Huck paint the fence by himself, or how long will it take him to paint the fence by himself. So, one of the things I want to start with always is what are some variables that stand for things in the problem. So I'm going to say R sub t, and I'm going to call that Tommy's rate. And R sub h will be Huck's rate. Now notice I used R there to indicate that these are rates, because this is how fast can they complete the job, right? And so the statement that Tommy can paint the fence in 12 hours means that 12 hours times Tommy's rate, and we'll just use 1 to say the job is completed. You could do 100% and it would just kind of change the way things look. Often, based off what the answer the student has here, I think that this will be simpler for me to do it as 1, right? It completes the whole job, right? So we're just going to leave that. That's a piece of information that we have. If his friend helps him and they work together, they can paint the fence in 1 hour. So now we have 1 hour times their rates together, right? So if they're working together, both of their rates are added, and it takes them 1 hour to complete the job. And so the equals 1. I'll make a little note here. Right, so that's what the 1 is, a whole job, right? So I could say if I wanted to, you don't need this as part of the problem, but I will kind of note, right, that 6 hours times Tommy's rate would be a half, right? If he can get the whole thing done in 12 hours, we're going to kind of work from the assumption that it's sliced up into intervals, which means, right? So I'm going to kind of come right in here, and I'm going to say, therefore, R sub t is 1/12, and I'm just going to do per hour there, right? So most of you probably kind of work with 1/12 as the numerical part of what R sub t is, but what it is 1/12 of the job per hour, okay? So we want to kind of keep track of the fact that that hour is in the denominator. All right, so divided through by 12 hours, so 1/12 per hour, or 1 job per 12 hours. All right, so I kind of made the, let's see, let's put this. Right, there's kind of where I divided through by hours, so that's 1 job for every 12 hours of work. If they worked for 24 hours, he would complete 2 jobs, right? We don't really have 2 jobs in this problem set up that way, but that's kind of the thinking that's behind that. But if you wanted to turn that into, this is also 1/12 of the job for every hour that he works. Right, that's kind of the assumption of the problem. All right, so now we're going to come down here. We're going to say 1 hour times the combined rates of the 2 is equal to 1. Now that I know R sub t, that means we have 1 hour times R sub t's rate becomes 1/12 per hour. Let's see, that's the best way to do it. Let's just put hours down at the bottom there for now. Plus R sub h, which is the unknown rate, is equal to 1. So what do we want to do? Obviously now is just solve for R sub h, right? So R sub h is equal to what? The 1 hour run through everything is kind of not interesting. So but when you do, this is going to be 1 is going to be 1 minus 1/12, which is 11/12. So in 12 hours, he could complete 11 of the jobs. And, you know, the better way to think about that is 11/12 of the job per hour. Okay? So now that's not the answer, right? If you come back up here and say, how fast could Huck make the vine by himself? So now I'm going to let T be how long it takes Huck to paint the fence, right? And so that'll be T times Huck's rate is equal to 1. Now I can substitute some stuff in. Therefore, it's T times 11/12 is equal to 1. So T is equal to, you're going to invert 12 over 11 hours. Okay, so 12 over 11 hours is the answer. So, and I like, let's see, probably should do what I did a minute ago, which is T hours and T hours. It's nice to stick those units on there sometimes, I think. All right, and lo and behold, that's the answers the student got. I hope this is helpful. And I'll just embed the video right below all the text.